Hi everyone, welcome to my channel Big Bang Chemistry, a complete solution of chemistry. In the series of molecular symmetry video lecture, today we are going to discuss the type of symmetry element and symmetry operation. So before starting the different type of symmetry element and symmetry operation, we must have small revision of symmetry element. So what is symmetry element? Symmetry element may be your what point, maybe your what an axis, right? Maybe your what one plane in a given molecule, right? And if we do any action, any transformation about this point, about this axis, or about this plane, which type of transformation we are doing? Either if you will do the what rotation, or if we do the what reflection, right? After this transformation, your molecule will achieve a new configuration, right? And if this new configuration is equivalent to the what original one, then the point or the axis or the plane will be your what symmetry element. If this new configuration is not equivalent to the what original one, right, then these point or these element, this point, this axis or this plane will not be your what symmetry element. Now try to understand the meaning of symmetry operation. So what is symmetry operation? See, symmetry operation is nothing, it is your what action, right? In the molecular symmetry, we don't jump, the two type of action only, either your what rotation or your what reflection, right? So the action which we are going to do, this rotation or this reflection, about which axis? About this point, about this plane, about this axis, and about this point. So those rotation or reflection, if we perform about this point, axis or plane, and after that if you are getting a new configuration of the molecule, right, and this new configuration of the molecule is equivalent to the what original structure or original geometry of the molecule, then this action will considered as a what operation or symmetry operation. If this new configuration is not equivalent to the what original one, then this action will not be your what symmetry operation, right? I hope that everyone is understanding the meaning of symmetry element and symmetry operation. Now let's try to understand the same thing with the help of one example. Take the one example of AB3L0 type molecule. See, if anyone want to get the command on the symmetry, molecular symmetry or symmetry operations, right, that person must be the what master of the hybridization or geometry of the molecule, right? So this molecule is what trigonal planar molecule, right? So first draw the geometry of this molecule. So this is what trigonal planar molecule. So this is what A, B, B and B. For our own understanding, just I am marking the B1, B2 and B3 all B atom, which is equal to B. So this is what B1, B2, B3. Now see, in this molecule many point, many axes are there, which will be your what symmetry element, but no need to discuss now that what are the points and what are the axes which is your symmetry element. We are trying to understand the meaning of symmetry element and symmetry operation. So in this molecule, when you will check this molecule, in this molecule take any one axis, right? So I am taking one axis, this axis, right? If about this axis, what is the axis? B3AX, right? About this axis, I am going to rotate this molecule by 180 degree. So what will happen when we will rotate this molecule by 180 degree? So this position of B3 will not change, right? But after rotation of this molecule at 180 degree, B1 and B2 will interchange its position. So what is the new configuration? You will get the new arrangement of the B atom, right, where B3 will be what remain as it is, B1 will interchange with B2 and B2 will interchange with B1. Now check, this is the what new configuration, second configuration, this is the first configuration. When you will compare it, then you will find the first configuration is equivalent to the what second configuration. So now check, about this axis we did the what one action, which is what rotation by 180 degree. So this axis will be your what symmetry element, right, and this is the action which is your what rotation. This action is nothing, it is your what rotation. This rotation will consider as a what symmetry operation, right. So this is the meaning of symmetry element and symmetry operation, correct. Now based on the type of rotation, what is the basis? Based on the type of rotation and reflection, right. Symmetry elements are of total 5 types. So how many types of symmetry element we are having? First one is your what proper axis of rotation, which is going to represent by Cn. The second one is your what plane of symmetry, which is going to represent by sigma. It may be your what vertical plane or it may be what your horizontal plane. Third one is your what inversion or center of symmetry which is going to represent by I. Fourth one is your what improper axis of rotation, which is going to represent by Sn, right. And the fifth one is what identity, which is going to represent by E. So I hope that everyone is understanding the meaning of symmetry element and symmetry operation, and how to identify the symmetry element and symmetry operation we will discuss in next video, right. So next video we are going to discuss the detailed introduction of proper axis of rotation with the different type of examples. Thank you very much.